Hello, my name is Carl Joseph Risol, and here we are again for another video. This is Performance Test number 6, and our topic for today is about convolutional coders. So what is it? So it is different from block codes in that the encoder contains memory, and the encoder it outputs at any time unit depending not only on the k inputs but also on m previous outputs. It is generated by passing the information sequence to be transmitted through a linear finite state shift register. So we have here our convolution coder rate. We have the transition table. We're going to discuss it, the state machine diagram, and the trellis diagram. So here we have our M0, our M1, and we have our three outputs also. We have our XOR here, and we're going to put our input. So in transition table, so rate is 1 1 3, thus 1 bit input and 3 bits output. So here let's we have a pointer. We have here our pen. So if m0 is equals to 0 and our input will become to will 0, so here we'll be going there. We'll be going there also. We'll be going there also. So 0 plus 0 plus 0 is equals to 0. So another is if here m0 plus m1, so 0 plus 0 will become to 0. And here is input plus m1, so will become 2. 0 plus 0 is equals to 0. So here our answer, 0 and 0. So the next state is a 0 0. So let's erase it. Our so our next output, our next input, I mean. So our next input will be if 1. So 1 plus m0 plus m1 is equals to 1. And here 0 plus 0 is still 0. And in our n3, 1 plus 0 is equals to 1. So here 1 0 1. So the next state is 1 0. So another example. So let's keep the input d1 and 0. So it will be easy to see the difference. So pen. We have here if m0 is 0 and m1 is equals to 1. So if our input is 0, so 0 plus 0 in our n1 now, 0 plus 0 plus 1 is equals to 1. Next here is m0 plus m1, so 0 plus 1 is equals to 1. And in our n3, 0 and input is 0, m1 is 1, so 0 plus 1 is equals to 1. So our answer is 1 1 1. So next is if our input value is 1, so we have here 1 plus 0 plus 1 is equals to 0 on our n1. So in our n2, so m0 plus m1 is equals still to 1. And here we have in our input, if 1 is the input and m1 is 1, so it will become to 0. So our answer is 0 1 0. So we have here 0 1 0. So let's just continuing the same formula here to fill this other box here. So if the current state of M0 and M1 is 1 0, so here are the outputs with different inputs here like 0 1 and also with 1 1. So next is our state machine diagram. So we have here 0 0, our current states, 0 0 here, 0 1, 1 0 and 1 1. So there we are. So if our input is 0, so it will be going back only to our 0 0. This is the next state. So if our input is 1, so the next state will be 1 0. We'll be going here. So 1 0. So here 1 0. So 1 0, if our input is 0, will become 2. The next output is 0 1. And if our input is 1, so our next state will be, have here 1 1. So in 1 1, if our input is 0, so the next output will be, the next state will be 0 and 1. But if our input in 1 1 is 1, so we have 1, 1 0 1. Here is the output, and the next state will be going back to only to 1 1. Still here. So next is our values in 0 1. So here is 0 1. If our input in 0 1, in the current state 0 1 is 0, so the next state will go to 0 0 there. And if our input here is 1, the next state will be 1 0. Oh, so it will going back. So it's only the same here. It's just a different arrows. So next is our trellis diagram. It's the same as in state diagram, in transition table, but in a different type of diagram. So we duplicate here the 0 0 0 0 0 1 0 1 1 0 1 0 and 1 1 1 1. So here we have 0 0. It will come back to 0 0. Then if our input is 1, so we have here it's going to 1 0. So in 0 1, if our input is 0, it will go to 0 0. If our input is 1, it will go to 1 0. So in 1 0 current state, if our input is 0, it will go to, we have here 1 0, it will go to 0 1. And if our input is 0, if 1, I mean, in 1 0, it will go to 1 1 here. We have here 1 1. So if our input in current state 1 1 is 0, so it will go to 0 1 here. So we have here 0 1. And if our input is 1, so it will only go back to here 1 1. So that is the trellis diagram. So summary, convolutional code is a type of error correcting code that generates parity symbol. It is are a bit like the block codes that they involve the transmission of parity bits that are computed from message bits. Trellis uses a convolutional code. So that would be all for today's topic. Thank you.